How are you guys? My name is Vincent Smoko, and today we are going to be discussing inference about the mean of a single population. So there is this graph that we use as a guide on calculating our test statistic and choosing our critical value. So if the variance is given and it's known, we use the first test formula to calculate the test statistic. And if the variance is not known, we need to consider whether the sample size is above 30 or not. If it is more than 30, we also use a formula which is more similar to the first one, which is the second, but a little bit different. Here, the only difference is that the first formula makes use of sigma, which is the population standard deviation, and the second formula makes use of S, which is the sample standard deviation. And if our sample size is less than 30, we use the T distribution. So this will get more clearer as I'll be using different examples to illustrate. So let's jump on to look at our first equation. So the first equation reads, the average mileage per liter of newly manufactured motorbike is reported to be 60 kilometers per liter of petrol. The researcher believes that this is too low. To evaluate this claim, a sample of 26 motorbikes were investigated to find their mileage per liter of petrol. The sample information is reported in the following table. So the following data set gives sample information that was collected. So here the variance is not known, and the observation that we are having in this case, they are less than 30. So let's solve it. So the first thing that we need to do is to state our null hypothesis. So under H naught, the null hypothesis reads mu is equals to 60. Then H1, the alternative hypothesis, mu is less than 60. Here we can see that our level of significance is not stated. So we use the default level of significance, which is alpha is equals to 0.05. So the default level of significance is 5%. So we go on to calculate the test statistic. So for this data set, we need to find the mean. So mean is given by x bar is equals to summation x over n, which is equals to 1467 over 26. Then our answer here is 56.4231. We go on to calculate the standard deviation. We start by the variance. So variance is equals to summation x squared minus n x bar squared over n minus 1. So this is equals to 85,293 minus 26 bracket 56.4231 squared all over 26 minus 1. So here we get a variance of 100.814 So the standard deviation S is equals to the square root of the variance. So this gives us 10.0406. So now we are ready to calculate our test statistic. So our test statistic is given by zcalc is equals to x bar minus mu over s over root n. So this is equals to 56.4231 minus 60 all over 10.0406 divided by root 26. This gives us negative 1.82. Now we want to determine the critical value. Our critical value, we first need to calculate the degrees of freedom. So df is equals to n minus 1, which is equals to 26 minus 1, which is equals to 25. So if we check, this is a one-tailed test. One-tailed tests are directional. By directional, it means on our alternative hypothesis, it's either we have a strictly less than sign or a strictly greater than sign. That means it's directional. If we have is not equal to on the alternative hypothesis, it means it's a two-tailed test. So here our critical value is given by T at 25 degrees of freedom. Then we are testing at 0.05. So this is equals to, let me check my tables. So I'm having 1.708. So if I draw my t distribution, then because I'm having a less than sign here, so my rejection region will be this side. So here I'll have a negative 1.708. So the decision rule is that we reject H naught, the null hypothesis, if the test statistic zcalc is less than negative 1.708. So conclusion, so my test statistic is 1.708. negative 1.82. So it's less than the critical value. So since Z calc is less than negative 1.708, the critical value, we reject the null hypothesis So if we reject the null hypothesis, we therefore conclude that the average mileage per liter of newly manufactured motorbikes is less than 60 kilometers per liter. Then that's it with the first equation. So now we go on to the next equation. The next equation is saying it is claimed that sport car owners drive on average of 18,000 miles per year. A consumer firm believes that the average mileage is probably lower. To check, the consumer firm obtained information from 40 randomly selected sports car owners that resulted in the sample mean of 18,463 miles with a sample standard deviation of 1,348 miles. What can we conclude about this claim? Use alpha is equals to 0.01. So we are testing at 1% level of significance. So here we state our hypothesis, and so it's under H naught mu is equals to 18,000, and under the alternative hypothesis mu is less than 18,000. Then our alpha is equals to 0.01. So this time around, we don't need to calculate the mean and the standard deviation because we are already given those results. So x bar is equals to 18,463. Standard deviation is equals to 1,348. And our n is equals to 40. So we just jump on to calculate the test statistic. Test statistic. Here, this one is a Z distribution because our n is greater than 30. So Z calc is equals to x bar minus mu. Mu is the hypothesized mean over S over root n. So this is equals to 18,463 minus 18,000 over 1,348 over root 14. This gives 2.17. So our critical value, again, this is a one-tailed test, so we want Z at 0.01. This is equals to Z at 0.99, and this gives us the critical value is 2.3262. Is 3 here. So since our alternative hypothesis, we have a less than sign, so our rejection region is on this side, and our critical value here is negative 2.3263. And our test statistic, this one is falling somewhere around here because in between here we have 0. So it's following somewhere here in the acceptance region, 2.17. So we then go on to put our decision rule. Our decision rule is that we reject H naught, the null hypothesis, if zcalc is less than negative 2.3263. So since zcalc is greater than negative 2.3263, the critical value, we fail to reject H naught, the null hypothesis. So we therefore conclude that on average, sport car owners drive 18,000 miles per year. That's how we deal with that question. And let's suppose we want to find the p-value for this question. So p-value is equals to the probability that Z is less than our test statistic, which is 2.17. So this will give us 0.982. So using the p-value to make the conclusion, our decision rule would be we reject H naught if p is less than alpha. And in this case, our p is greater than alpha. Mind you, our alpha value is equals to 0.01. So our p is greater than alpha, so we are failing to reject the null hypothesis. So now let's go on to question number 3. Question number 3 reads, in a frequently traveled stretch of the I-75 highway, where the posted speed is 70 miles per hour, it is thought that the people travel on average of at least 75 miles per hour. To check this claim, the following radar measurements of the speed in miles per hour is obtained for 10 vehicles traveling on the stretch of the interstate highway. Do the data provide sufficient evidence to indicate that the mean speed at which people travel on this stretch is at most 75 miles per hour? So under H naught, our mu is equals to 75 miles per hour. Then under H1, mu at most, so it means mu is less than 75 miles per hour. And here we are given alpha is equals to 0.01. So we go on to calculate the test statistic. So for the data that we are given, we need to find the mean. So x bar is equals to summation x over n, which is equals to 743 over 10. This gives us a mean of 74.3. miles per hour. Then our variance is equals to summation x squared minus n x bar squared over n minus 1. This is equals to 85,519. Sorry, this is 55,000. 55,519 minus 10, 74.3 squared over 10 minus 1. So the variance is 34.9. And the standard deviation is the square root of the variance, so it is equals to 5.90762. So our test statistic here, we can use Z for the test statistic, or we can use T. So it all depends with what you want and what you are used to. So T calc is equals to x bar minus mu over s over root n. So this is equals to 74.3 minus the hypothesized mean 75 all over 5.90762 over root 10. So the test statistic in this case is negative 0.3747. So we now want to determine the critical value. So the first thing is to calculate the degrees of freedom. df is equals to n minus 1, which is equals to 10 minus 1, which is equals to 9. So the critical value is t at 9 at 0.01. So our critical value is equals to 2.82. And since we have a less than sign on our alternative hypothesis, so it's going to be negative 2.82, and here is the rejection region. So the decision rule is that we reject H0 if T calc, the test statistic, is less than negative 2.82. In the middle we have 0. So if we take our test statistic, we will notice that it will fall somewhere around here. So since T calc is greater than negative 2.82, we fail to reject H0. Then we conclude that the speed at which people are traveling is 75 miles per hour. So that's how we go about this one. So let's look at the next question, which is question number 4. Question number 4 reads, in attempting to control the strength of waste discharged into nearby river, an industrial firm has taken a number of restorative measures. The firm believes that they have lowered the oxygen consuming power of their waste from the previous mean of 450 manganite in parts per million. To test this belief, readings are taken on n is equals to 20, so the sample size is 20, successive days. A sample mean of 312.5 and a sample standard deviation of 106.23 are obtained. Assume that these 20 values can be treated as a random sample from a normal population. Test the appropriate hypothesis. Use alpha is equals to 0.05. So here we need to note that our sample size is less than 13, and hence we are going to use a t-distribution. So again, we need to first state the null hypothesis, which is mu is equals to 450. Then our alternative hypothesis is mu is less than 450. And we are testing at alpha is equals to 0.05. So our x bar is equals to 312.5. S is equals to 106.23. And n is equals to 20. So our test statistic T-calc is equals to x bar minus mu over s over root n, which is equals to 312.5 minus 450 over 106.23 over root 20. So then this gives us let me quickly work it out. So on this one, our critical value we need to first find the degrees of freedom, which is equals to n minus 1, which is equals to 20 minus 1. This gives us 19. So this will give us our critical value is t at 19, 0.01. This is equals to 2.539. Okay, now going back to our test statistic, we have a sample size 20, Then the mean is 312.5. Then our standard deviation is 106.25. Then the hypothesized mean is 450, and we are testing at 0.01. So in this case, our test statistic is negative 5.7875. So we draw our distribution. So since our alternative is less than, so our critical value will be negative 2.539, and this is the rejection region. So here we will notice that our test statistic, this one, is falling somewhere around here. So our decision rule is we reject H naught, the null hypothesis, if T calc is less than negative 2.539. So since T calc is less than negative 2.539, we reject the null hypothesis. So we therefore conclude that the restorative measures that have been taken by the industrial film have lowered the levels of manganite parts per million, because we have rejected the null hypothesis. Now let's go on to question 5. Question 5 reads, among 157 Zimbabwean men, the mean systolic blood pressure was 146 with a standard deviation of 27. We wish to know if, on the basis of this data, we may conclude that the mean systolic pressure for a population of Zimbabwean men is greater than 140. So here our null hypothesis is mu is equals to 140, because that's the hypothesized mean. The 147, if you read the question carefully, you will notice that it is the sample mean. So x bar is equals to 146 and s is equals to 27. Our n is equals to 157. So this one is going to make use of the z distribution. So under h1, mu is greater than 140. We are using alpha is equals to 0.01. So now we calculate our test statistic. Z calc is equals to x bar minus mu over s over root n. This gives 146 minus 140 over 27 over root 157. So we get a test statistic of 2.7844. So our critical value is Z at 0.01, which is equals to Z at 99, since the normal distribution is symmetric. So this gives us 2.3263. So if we draw our normal curve, our critical value, since we have a greater than sign now, so our rejection region is on the right side. So it's 2.3263. So this is the rejection region. So this is our test statistic, and we reject the null hypothesis if it falls here, and we can see that it's somewhere around here. So our decision rule, don't forget to put your decision rule. So decision rule, we reject the null hypothesis if zcalc is greater than 2.3263, the critical value. So since zcalc is greater than 2.3263, we reject H0, and we therefore conclude at 1% level of significance that the mean systolic blood pressure for a population of Zimbabwean men is greater than 140. So that's how we go about that question. Now let's look at question number 6. Question number 6 reads, the management of a local health club claims that its members lose on average 15 pounds or more within 3 months after joining the club. So 15 pounds is the hypothesized mean. To check this claim, a consumer agent took a random sample of 45. So our N is equals to 45 members of this health club, and found out they lost on average of 13.8. So this is X bar within the first 3 months of membership, with the sample standard deviation of 4.2 pounds. So the question is, find the p-value for this test. Right. So under H0, mu is equals to 15. This is what was claimed. Innocent until proven guilt. So under H1, the alternative hypothesis, mu is less than 15. Why less than 15? because the researcher, for them to collect this information, they believe that it can be lower than this. So our alpha is equals to 0.01. So now we want the test statistic. So zcalc is equals to x bar minus mu over s over root n. This is equals to 13.8 minus 15 over 4.2 over root 45. And this is equals to negative 1.9166. So the p-value, how do we obtain the p-value? It is p-value is equals to probability that z is less than negative 1.92. So if we draw negative 1.92 is this direction, so this is equals to 1 minus phi 1.92, which is equals to 1 minus 0.9712, which is equals to, so the p-value is 0.0288. Decision rule, using the p-value, we reject h naught if p is less than alpha. In this case, our alpha is equal to 0.01. So since p is greater than alpha, we fail to reject h naught. So we therefore conclude that the members lose on average of 15 pounds within 3 months of joining the club. So that's how we deal with question number 6. Let's go on to look at question number 7. Question number 7 reads, the mean age of policyholders at World Life Insurance Company determined 2 years ago was found to equal 32.5 years, and the standard deviation was found to equal 5.5 years. The mean age of the sample of 50 policyholders is determined to be 34.4 years. It is reasonable to believe that the mean age is increased. However, some of the older policyholders are now deceased and some younger policyholders have been added. The company determines the ages of 50 current policyholders in order to decide whether the mean has changed. So here we want to determine whether the mean has changed because we don't know whether there has been an increase or not. So this one is going to be a two-tailed test. So under H naught, mu is equals to 32.5. Then under H1, mu is not equal to 32.5. And we are testing at alpha is equals to 0.05. Now we want to determine the test statistic. Test statistic is given by z calc is equals to x bar minus mu over s over root n. So this is equals to 34.4 minus 32.5 over 5.5 over root 50, and this gives us 2.4427. Now we want to determine the critical value. So because it's a two-tailed test, we have two rejection regions. So we have one rejection region and the other rejection region. So our alpha is going to be divided into two. So our critical value will be z at alpha over 2, which is equals to z at 0.025, which is equals to z at 0.975. So this gives us critical values of 1.96, negative 1.96 and 1.96. So our decision rule is that we reject H naught, the null hypothesis, if the absolute value of the test statistic is greater than 1.96. So this is our test statistic, and we can see that it's falling somewhere here. So our conclusion since the modulus of z calc is greater than 1.96, we reject H naught, the null hypothesis, and we therefore conclude that the mean age for the policyholder has changed. Then that's how we do with questions of this nature. So I'm now going on to the last question that I'll demonstrate, which is question 8. A quality assurance inspector periodically examines the output of a machine to determine whether it is properly adjusted. When set properly, the machine produces nails having a mean of 2 inches with a standard deviation of 0.07 inches. For a sample of 35 nails, the mean length is 2.025 inches. Using the 0.01 level of significance, examine the null hypothesis that the machine is adjusted properly. Determine and interpret the value, the p-value for the test. Okay. So under H naught, mu is equals to 2, innocent until proven guilty. So we don't say it's not adjusted properly until data proves so. So under H1, mu is not equals to 2, meaning that it's not adjusted properly. So here we are told that x bar is equals to 2.025. S is here we are given the standard deviation. So it's not S this time around, it's sigma. So sigma is equals to 0.07. N is equals to 35. Right. So our level of significance alpha is equals to 0.01. So our test statistic is given by zcalc, test statistic, zcalc is equals to x bar minus mu over sigma over root n. So this is equals to 2.025 minus 2 over 0.07 over root 35, which is equals to 2.1129. So the critical value is Z alpha over 2, which is equals to Z at 0.005. So this is equals to 2.5758. So because it's a two-tailed test, we have two rejection regions. So here we have negative 2.5758, and here we have 2.5758. So the decision rule is that we reject H naught if the absolute value of zcalc is greater than 2.5758. So here we can see that the test statistic is falling somewhere here, and it means that we are going to fail to reject the null hypothesis. But we want to use the p-value to determine our hypothesis. So let's do the calculation for the p-value. So our p-value is given by p-value so since it is a two-tailed test, it's going to be given by 1 minus two bracket 1 minus phi two point 1129. So this is equals to 1 minus, let's check out the probability. Zero point 0.98 27. So the answer is equals to, for the p-value, 0.0346. So our alpha, we reject, decision rule is that we reject H naught if P is less than alpha. So in this case, our P is equals to 0.0346, and our alpha is equals to 0.01. So since P is greater than alpha, we fail to reject H naught. So if you are failing to reject H naught, we therefore conclude at 1% level of significance that the machine is properly adjusted. So I've done 8 out of the 10 questions that I had for you. So I'm going to leave these 2 questions, question number 9 and question number 10, for you, but the basic idea is just the same behind these questions. So if there are any questions concerning this topic, please feel free to get in touch. Otherwise, thank you. Please like and subscribe to my channel, and also share these videos to anyone who might benefit to them. Otherwise, cheers.